Colby, math.com.
We worked today on relearning something you've learned in previous years about mean, median, mode, and range, and how to calculate those measurements of data sets. And so we'll practice that together on number 4. Number 4 says find the mean, median, mode, and range of heights for the pyramids listed in the horizontal bar graph below, and round to the nearest whole meter when necessary. So sometimes your data will be given to you in numeric form, as you see on the first 3 problems, and then sometimes it will be given in a graphical form, in this case a horizontal bar graph, which is less common than a vertical bar graph, but serves the same purpose. We can just compare the lengths of these bars to see which pyramid has the greatest height, which pyramid is the shortest, and bar graphs let you compare data in categories. In this case, the categories are these different pyramids located at different parts of the world. In order to find median, we must order the data from least to greatest, but it's also helpful to have that ordered data set when finding the mode and range. And so let's first order the data, but first we need to know what the data is. So this bent pyramid in Egypt, if I follow this line down, I see that it's 100 meters high, or tall. The Great Pyramid of Cheops in Egypt, the tallest of these pyramids, is, well, it's between 140 and 150, and it looks like it's halfway between, so I'm going to say 145, and I think it's helpful to put the data right next to each one of these bars. The Inca Pyramid in Peru is between 70 and 80, and so let's say 75 for this. The Pyramid of the Sun in Mexico is 60 meters. The Pyramid of the Sun in Peru is 50 meters. And the Step Pyramid in Egypt is 60 meters. So now we have the data. We can make our set of data from least to greatest. The least would be 50 meters, followed by 2 pyramids which are 60 meters each. So we've done these 3. 75 meters is next, followed by 100, and then the tallest pyramid is 145. It's always good to count your data after you make your ordered list. I have 1, 2, 3, 4, 5, 6 data points in my list, and I started with 1, 2, 3, 4, 5, 6 pyramids. The mode is the easiest measure of the data to find because it's the data that occurs the most. 50, 75, 100, and 145 all occur once, but 60 occurs twice. And so the mode is clearly 60 meters for this data set. The range is also pretty easy to find. We learned the song, mean, the average, mode, most often, range, subtract the smallest from the largest. So 145 is the largest, and we subtract the smallest from the largest. 145 minus 50 gives me a range of 95 meters. Median, the middle number when you line them from the greatest to the least or least to the greatest. And if we're looking for the middle, rather than cross them off, because I'd still like to be able to see them when we calculate mean, I'm just going to underline them in pairs, underline the least and the greatest, underline the next least and the greatest, and we see we have 2 in the middle. And whenever you have 2 in the middle, you need to find the average or the mean of those 2. So 60 plus 75 divided by 2. If you can also have a shortcut if you know the number that's right in between, like right at the midpoint of those 2, but it's difficult when one is even and one is odd, like it is in this case. So let's just use this method. 60 plus 75 is 135, and then let's divide 135 by 2. There are 0 2s and 1. There are 6 2s and 13 because 6 times 2 is 12. Subtract, I get a difference of 1 and bring down this 5. There are 7 2s and 15 because 7 2s is 14. subtract, I get a difference of 1, and so I know that this median is 67 and 1 over 2, or 1/2. If we're dividing by 2, we're counting halves, and so if I have a remainder of 1, I have 1/2. So 67.5, but the directions tell us to round to the nearest whole meter when necessary, which means when you get something that's not a whole number of meters like the first two were. And so 67.5 would round to 68, even though it's exactly this, that 67.5 is no closer to 67 or 68 than it is to 67, but the convention is to round up when it's 5 or more. And so we'll list 68 meters as our median. And I'd like you to find the mean during the break. This is something we practiced in class, so refer to your notes. Mean the average, so if you know how to find the average of these 6 numbers, do that during the pause and come back and see how you did.
Paused.
The average is the sum, the average or the mean is the sum of these 6 numbers divided by 6. And so let me write an expression. I'm going to scroll down a bit. 50 plus 60 plus 60 plus 75 plus 100 plus 145. That sum will be divided by 1, 2, 3, 4, 5, 6 pieces of data. And I'm going to add these in a way in which I associate to my advantage. I'm going to add 75 and 145 because the 5s go together and make 10. 10 and 70 is 80, and 80 and 140 is 220. So I have 220 plus 60 and 60 is 120, plus this 100 and this 50 will make another 150. I'm going to divide all that by 6 once I know the sum. 220 and 120 is 340, plus 150 is 490. So we have 490 divided by 6. And then let's divide 490 by 6. There's 0 6s and 4, but there are 8 6s and 49 because 8 times 6 is 48. Subtract, you get a difference of 1 and bring down this 0. There's 1 6 and 10. 1 times 6 is 6. Subtract, you get a difference of 4. You see we'll have 4 6 as our remainder, which is 2/3. So you may already know how to do the rounding from that. It's closer to 1 than it is to 0, but let's just bring down this 0 in the tenths place, line up the decimal in our quotient, and how many 6s are there in 40? 6 times 6 is 36. And the 81 and 6/10 will round to 82 meters for the mean. And then when you look at the data, 82 meters would be, over here somewhere, which is still somewhat near the middle of the data. Not super in the middle, but it's because we've got this really high, really tall pyramid that pulls the mean a little bit. It's not, I wouldn't call this an outlier, but it does pull the mean to the high side, and so it does look reasonable. And so these are all of the values for this problem. I hope that helped you with the assignment. I hope we can transfer some of those ideas to the other problems if you're having trouble. Thank you for watching the video, and I'll see you tomorrow.